Guys, I'm Jameson O'Connor, and today I'm going to be presenting my final project for data collection. I did my project on a dataset I found in Kaggle that highlights the sales from a certain store on Black Friday last year. What the store wants to know is there any way that we can predict based on a category of shopper what they will buy or how much they'll purchase more specifically? This way, they can target advertising to their customer, or maybe find out where they're falling short on a different category of customer. So I went out with a goal to create a model that would predict, given this consumer, how much would they purchase. Um, so I started my data exploration, got familiar with some of the variables that I'm going to present to you right here. So the first variable is the user ID. So this is the unique ID of a shopper. The product ID, which is, again, just a unique key to the product that they bought given a transaction. And then the breakdown, or the categorical breakdown of a user, of a consumer, sorry. Gender, age, occupation, a couple more. And then the purchase amount. So this is how much a transaction actually was. If I bought product ID A, I spent X amount. This is the variable that's checking purchase, and this is where we want to optimize purchase. We want to see more transactions, and we want to see people spending more. That's the goal of this model, and what the store really wants from this data set. So I go through some of the steps of cleaning the data, removing outliers, as you can see with the box plots. And then once the data is all clean and I'm happy with the data set, I back it up to a database. I'm going to query this database, but I think it's also important that I hand over something that the store could use to verify against my data and my findings that I eventually will present to them. I feel that SQL is a little bit more universal than R scripts. So starting off, I wanted to analyze my first variable of gender, see which customer, not which customer, but what customer was coming through the store more often. Who was their most frequent customer on Black Friday, rather. So I do a query to my database, and I break it down off of gender. As you can see, a lot more males come to this store than females on Black Friday. But when you look at it from an average, females only spend 8% less than males. So one of my suggestions that I would write up in my final report is that the store could do a better job marketing to women. They're spending close to the same amount as men, but show up less than half of the time to Black Friday. So is there a way that you could toggle your advertising so that more women come in, more women are spending, higher traffic? I'm sorry I have to fly through these. There's just not a lot of time for this presentation. So the next one that I analyzed was age. I wanted to see who was the most frequent customer to the store on Black Friday. The most frequent customer was a customer between the ranges of 26 and 35 years old, with 0 through 17 and 55 plus being the least frequent customer for Black Friday transactions. I think that's important for them to know. But then what's also important for them to know is who's spending the most on average. And it turns out that on average, the 51 to 55-year-old consumer is spending just a tad more than everyone else. They're all spending approximately or close to the same amount, but the 51 to 55-year-old is buying more expensive products on average. So something that they could do is they could look at this and say that they're not getting enough traffic from that age range. And again, how can you market to those people? How can you set up deals that they will buy more stuff? because they're buying more expensive products at the end of the day. Flying through this again, the occupation of the customer, I just wanted to see which occupation was buying more, if there was a certain trend to it. You can see that occupation does play kind of a role with occupation 4, 7, and 0 standing out. It's unfortunate that this data is so anonymous. I wish I could say that it's that like plumbers, if category 4 was plumbers as an occupation, that plumbers are buying the most, and it might be a supply store, for example. But continuing on, I just wanted to see how they were distributed, if there was more of a trend there. Looking at analyzing city, so analyzing the customers from city A, B, and C. Customer B was more frequently bought from this store compared to city A and city C. I wanted to look at their total spend. City B spent more than city A and city C. And then I wanted to look at the time in city and who was spending more if they lived in the city for less than a year, for 2 years, for 4+ years. And it turns out that if you live in the city for 1 year, those customers were buying a lot more than everyone else on average. Continuing down, the last one I analyzed is marital status. The store sees a lot more traffic from unmarried customers compared to married customers. So, going to continue down. I close out my database so that I can focus on my models. I create my training and my test set so that I can test my models and validate. So this is where I start, and this is to answer the question of like, how can we increase sales, or can we see a certain pattern of categorical consumers spending more? So what I did was I created my equation, giving it all the variables that I thought could affect how much is spent on a certain transaction, how much they spend altogether. And as you can see, there's not much of a correlation at all. This model was really hard to get to fit this data. I was getting R-squared values of 0.009, which is very, very bad. And I kind of hit a wall here. I felt that I couldn't come up with a model that would really do the prediction and really answer the question that I was shooting for. So I had to adjust and I had to pivot my question. One thing that I saw through my analysis first was that the store made more when a certain customer came in, right? So we saw that the age range 26 to 35 was the most frequenting customer. They bought the most. That they also spent the most money altogether as a unit. So I wanted to verify that trend, and what I did was I set it up a smaller linear model that is based off of, where is that? Excuse me. That is based off of count. Here. So I wanted to see how well purchase was explained by how much product they were buying. And as you can see, this fits very well. There's a strong correlation between buying a lot of product and the money in the end that the store would get. Seems like an obvious point, but is very important for my last analysis. So my last analysis, I had to pivot the question and give them something valuable, right? I wanted to give the store something pretty valuable that they could use. And what I looked up and what I resolved to was this a priori analysis. A priori is the thing that once you watch a Netflix documentary, they suggest 3 more. Or once you buy something in Amazon, they're like, users also bought A, B, and C. And this is what I wanted to do. I wanted to look at their whole product suite. I wanted to create this a priori matrix so that I could say that a consumer who tended to buy A will also buy C and D, and some combination of that. And this is valuable to the store, so they could set up promotion deals. They could, if it's a physical store, they could put product A, D, and C in the same aisle so that maybe that consumer will buy all three, and in the end, increasing the purchase power, which is what we set out to do. So this is me setting up the a priori matrix. This is me testing the a priori matrix when I'm looking at products with the product relation. I had to lower my confidence so that I can say that with 75% confidence, these things hold. And these things specifically are right here. So I can say in this scenario here with 80% confidence that the consumers who bought this product ID, this product ID, this product ID will also buy this product ID. This is also given a lift value, meaning that this is supported by the data significantly. If this was 1, then it'd be very rare for this to happen, or it would just happen normally in the data. That's what lift really stands for. But as you can see, this happened 57 times in our data set and 67 times for this combination of products bought. So I created this scatter plot that shows a little bit about my confidence for certain points for these certain association rules. And this is what I eventually would hand to the store as my conclusion and as my suggestion for them to increase sales. So that's it for today. A little bit over time, but I hope that you guys gained some knowledge from this, and thanks very much.